This video is about how to find the positive and negative intervals for particular functions. So basically when I say positive and negative intervals, I want to know where the graph is above the x-axis and where it's below the x-axis. But this time I don't actually have a graph to look at, right? If I had the picture of the graph, I could say, oh, this piece of the graph is above the x-axis, this piece of the graph is below the x-axis. However, what I want to do now is do it analytically, meaning given the equation, could we figure out where the intervals are positive or negative? Okay, so let's do number 12 here. Number 12. So the function, I'll go ahead and write it down. F of x equals 3x squared times x squared plus 4 x minus 2 over x minus 4 squared x plus 2 squared. Okay, a lot going on in this problem, but each piece is important here. So, and we want to know, so number 12 says where the function is less than 0. Let's talk about that part first. So, we want to know where the function is less than 0. So, think of a number that's less than 0, negative 1. What's another number? Negative 5. So, basically, we want to know where the function is negative, where all the y values, or the function values, are less than 0, meaning negative. So I want to know where the negative intervals are for number 12. Where is this graph, without drawing a picture, where is it below the x-axis? Alright? And the way that we determine that is, well, we can do this. Let's find out where the graph does cross 0, right? Because those are important, critical points. Correct? So as we're graphing, right, the graph's going to go up and down, round and around, and it's going to cross the x-axis somewhere. So we want to find the spots where it crosses the x-axis, or we want to find where the function does equal 0. Okay? So we want to find where the function does equal 0. Let's look at the numerator, correct? Because in a fraction, okay, in a fraction, if I have 0 over 5, what's 0 over 5 equal? That equals 0. If I had 0 over 7, what does that equal? 0. So I want to find out where the numerator equals 0. Okay, so I'm just going to rewrite it here. So this piece, this piece. Okay, so let's find out where the numerator equals 0. So those would be my critical points that I know where my intervals are going to have to either stop or continue, things like that. Now, luckily for us, we already know how to solve this, right? Because it's already in its factored pieces, so we set each piece equal to 0. So 3x squared equals 0. So if we divide by 3, oh, there's another example. 0 divided by 3 is still 0. And if I take the square root of 0, so x still equals 0. Okay, so that's one spot. All right, this one here, so x squared plus 4 equals 0. Subtract 4. All right, x squared equals negative 4. All right, I hope you guys see what's happening here. If I take the square root of a negative, remember this becomes imaginary, okay? But what does that mean in the context of what we're doing here? So if it's imaginary, that means there's no place where it crosses x. Meaning this factor right here, x squared plus 4, has no roots, meaning it has no x-intercepts. It's never going to touch the x-axis. So we don't care about this part, okay? So we're just going to ignore that because that piece or that part of the function won't actually cross the x-axis. So that's not going to help me know if the graph's above or below the x-axis. It will just be a continuing part of it, okay? So we're going to ignore that part because we got something imaginary. And then this part, x minus 2 equals 0, simply add 2, x equals 2. Okay, so these are the spots where it equals 0, at 2 and 0. Okay, good to know. All right, now, here's what we have to be aware of. So the original function's a rational function, right? A fraction kind of polynomial. So in a rational function, not only do I have to find out where it crosses equals 0 by using the numerator, we have to look at the denominator. Here's why. Because, so for 0, for example, if I plug in 0 into the denominator, what can't I have in the denominator, right? My denominator can't be 0. Remember, we hopefully have learned through grade school and other things. If I had 2 over 0, that's not possible. That doesn't equal 0. This is something that we call undefined. Okay. So we can't have our denominator equal 0. So we need to find those spots where the denominator equals 0 so we can avoid that in our intervals, okay? So the first thing we did, we set the numerator equal to 0 to find out where those critical points are. That's good. Now we need to find out where my trouble spots are, meaning in my intervals I have to exclude these values. So I look at the denominator, and we're going to set that equal to 0 to find out where my issues might lie. So x minus 4 squared and x plus 2 squared. Okay, so we're going to find out where those two pieces equal to 0. Again, it's already in separate pieces. So I'll set this part, x minus 4 squared equals 0, square root, x minus 4 equals 0, add 4, and x equals 4. Okay, so that's a trouble spot in my domain, so I can include that. Okay, here we have x plus 2 squared equals 0, square root, x plus 2 equals 0, subtract 2, x equals negative 2. Okay, so that's another trouble spot in my domain. Okay, so here's what all that means. So I found the spots where my graph equals 0, because that's going to help me with my intervals, right? Because those are the critical points, whether the graph goes above or below that particular value. And then x equals 4 and x equals negative 2 are two spots in my domain because I can't plug in those values for x, because if I did, my graph would be undefined. So I definitely don't want that. Okay, so I'm going to go ahead and make my number line here. All right, I'm going to put all the values I got. Okay, so we'll start with the smallest one, which was negative 2. Then it was 0. Then 2. Then 4. Okay, now, so in my graph, for whenever I have domain issues, which is what I did in blue here, whenever I have domain issues, I can't include those, right? Cannot include those. So on my number line trick here, I need to put open circles on negative 2 and 4, right? Because when I write my intervals, I need to remember I cannot include negative 2 and 4 because that would make my denominator undefined or my whole function undefined. All right, now for 0 and 2, where the spot actually equals 0, we have to look carefully at what it asked for. So we want to know where the function is less than 0. If it said less than or equal to 0, I would put closed dots on 0 and 2 because it could equal 0. That means I can include it. But it says less than 0, meaning I don't want to know where it equals 0. I need to know everything less than it. So I also need to put open circles on 0 and 2 because I cannot include where the graph equals 0. Okay, so that's the open circle thing. Lastly, here we go. Now we look, so all these different intervals, we're going to go from right to left, and vary against common English or American tradition. We're going to go from right to left in order to do this number line trick. And one careful thing to point out, we ignore domain. Okay, so we ignore the domain restriction. So I'm going to put like a D next to the negative 2 and the 4 because domain restrictions aren't a part of this trick. The only part of the trick I need to be concerned about is with the parts that make it 0. Anything that's the domain excludes, skip over. Only parts that deal with the roots or the critical points is what I deal with. So this function starts off with a positive 3. So on my right side here, I write a positive. Oh, I see 4 as part of the domain, so I skip over that. It stays positive. All right, so at 2. All right, I got 2 from this interval, from this part right here. And this particular factor is to the first power. And whenever it's an odd exponent, wherever I got that factor from or that critical point from, wherever I solved it from, we flip the sign. So it was going positive, so now we're going to change it to negative. Okay. All right, at 0, which is where I got 3x squared from, okay, notice how it's squared, okay? So the variable was squared where I got 0 from, so that means my sign flips. So it was negative, now it changes to positive. Okay, and then again, negative 2 is part of the domain, so it continues to be positive. All right, now, last step here. I need to determine where the graph is less than 0, meaning where is the graph negative? Which, again, if we do our work here, it's this one piece right there, correct? So from 0 to 2. So, and remember, it's open circles. What does that mean, bracket or parentheses? That means parentheses. So the only spot where my function is below the x-axis, or it's less than 0, is from 0 to 2. Phew, okay. That is how we do that number line trick and to find out without graphing where the function is less than 0.